record the lesson today. Okay, so a magnet, the North Pole will always look for the North Pole, the Earth's North Pole. This North Pole is actually known as the geographic North Pole. And then this one is known as the geographic South Pole. Okay, but the Earth is actually like a very huge magnet. So the Earth is actually like a huge magnet, which here is a south and here is a north. Okay, so this is known as what? The magnetic South Pole. Then this is known as the magnetic North Pole. Okay, so that's why this one looks out for the south, this one looks out for the north. So it always points in towards the geographic North Pole. Alright? Hey, give them eat lah, those just come. Give lah. Oh, Manin sure one. Don't pass, save one for him. Jack don't eat one. Okay. So remember, everything is easy. There are two poles. They are always point in the same direction when suspended freely. So when a magnet will always point in what we call the north-south direction. Okay, write out the word north-south direction. Okay, so the north will point to the north, the south will point to the south. The north is known as a north-seeking pole. It seeks out the Earth's geographic North Pole. Okay, but in actual fact, the Earth is the South Pole there. That's why it's pointing there. Okay, very easy. The law of magnetism, all you know already. Learned before. What's the law of magnetism?
Light poles attract.
Yeah. Light poles attract or repel? Repel. So, unlike poles, attract. Okay, so very simple lah, north and north, repel lah. Okay, so all this I don't have to explain, you learned before primary school, long time ago. Okay, so certain things, as I said, this chapter, the theory, the idea behind it, quite simple lah. Only problem comes when they ask you questions that you don't know how to explain lah. Like they can ask you how do you test whether something is a magnet? Describe experiment to test something is a magnet. Then a lot of people don't know what to say. They will say take a magnet, see whether it can attract paper clip. Does that prove there's a magnet? Maybe the paper clip, can the paper clip be a magnet? Yes. Can, right? So how do you test something? Okay, you just simply have to say, okay, you suspend something here, or whatever you want to test, put it on a string, hang it from the retort stand. Then you bring another, okay, so this one is the magnet. So this is the magnet that you hang. Then you bring the specimen. If it attract, it may not mean it is a magnet. Correct or not? It can just mean it is a, what we call unmagnetized magnetic material. Right? So it doesn't mean anything. But you take the other end, you switch ends. So first you do it N1, then after that you take to N2 and you put it close, and then it got attracted. Then confirm what is it? It is simply a unmagnetized material. That means both ends got attracted. So it is just simply a metal. But however, if one end got repelled, okay, so I bring here, then this end got repelled, then what does it mean? It's a magnet. Okay, so your repulsion is your only sure test. Okay, so it must repel something. Okay, it must repel the other one. Usually repel only, that means confirm that one is a magnet already. Okay, so you take note of these terms here. It sounds confusing. Magnetized magnetic material, that's a magnet. Unmagnetized magnetic material, okay, those are things which can become a magnet but they are not magnetized yet. And simply non-magnetic materials which cannot be made into a magnet. So different terms here. I think you can see the difference. Just be careful with it. Alright? Okay, so not difficult. Okay, and then after that, magnetic and non-magnetic materials. So magnetic materials which are attracted by a magnet. Okay, non-magnetic cannot be attracted by magnet. So all the examples listed there very simple. Just take note of things like that. I hope you know lah. Things like brass, aluminium, copper, can it be made into a magnet? Copper?
Cobalt.
Cannot. Alright? But iron, cobalt, nickel, all these can. Alright? Okay, very easy. Okay, first important term is this, magnetic induction. What is magnetic induction? This one everyone knows. So if you have a magnet like this, and you put one paper clip here or a pin here, this paper clip or the pin will become a magnet. So it can attract another paper clip or pin. Okay, very easy. Must it be touching? Don't need. This also is possible. Why? Because it's within where? Something you cannot see. Magnetic field. Okay, there is a magnetic field around here. You can't see it. But this magnetic field is making this into what we call a induced magnet. So the word induced magnet, okay, what does it? So it simply induces magnetism into it, right? Okay, so the definition is the process when a magnetic material becomes an induced magnet when you place it near or in contact with a magnet. Okay? Then all this is very, very obvious. I think all of you know. I should guess that you all will know that if this is a south pole here, the top here, Ian will become a... This is an induced magnet, right? Here south, then here will become a what pole? North. Then here will be? Then this one? Yeah. Okay, as simple as that, right? So you will know that. Okay, later on, then I will focus on the phrasing of the answer for this. Okay, so here I give you a generic way of how to phrase. But later when we talk more about induced magnetism, then I will explain further and get you to practice writing it down. Okay, so you cannot see it, but there's something around the magnet that is known as a magnetic field. So the definition again, maybe the worst thing in this chapter is the definitions because you need to memorize it. Okay, the magnetic field is a region around a magnet where a magnetic effect takes place. Okay, made out of magnetic field lines or made out of lines of force. Okay, so the field lines never cross each other. When you draw at a time, they shouldn't cross. And the field lines, the closer the field lines, the stronger the magnet, obviously, right? Then obviously, or maybe you may not know but I think you can guess the magnetic field lines always point from where to where? North to south, south to north. North to south. Okay, north to south. Okay, and then after that, when the magnetic field lines are closer, it indicates a stronger field, stronger magnetic field. And when they are evenly spaced out, okay, if the magnetic field are evenly spaced out, nicely spaced out between each other, we call it a uniform magnetic field. Okay? Okay, the main thing here is this. They are going to ask you to draw the magnetic field. So how do you draw the magnetic field? It is not very difficult. It is quite easy. So let's say, okay, my diagrams here are all very small. So I draw a bigger one here. Okay, let's say I got a magnet here, north pole, south pole. Okay, I ask you, which part of the magnet is strongest?
North.
Where is it strongest? The ends, the side, the center. Everywhere. Center the strongest.
Wait, what's the question again?
Where is the strongest part of the magnet?
At the tip.
At the
very
ends.
end.
The ends should be the strongest, right? Yes, so you are right. So the ends strongest means that you cannot draw a butterfly. So I get this. Some people draw one nice butterfly come out like that. This is totally wrong because your magnetic field is strongest at the ends. It cannot be like this. Okay? So how should you draw it? Very simple. Simple to draw. Draw it in this manner. Okay, the lines must touch a magnet. Okay, first of all, the lines must touch a magnet. I got some people draw very nice, but they don't touch. So they just draw like that. Wow, very nice, you see. Then they draw it nicely spaced out everything. I got to mark them wrong, no? Because it's not touching the magnet. Okay, so make sure it touches the magnet. Make sure it's symmetrical. So you're going to draw 2 lines on top, 2 lines on bottom, 1 in the center. Okay, don't like 5 on top, 3 below kind of thing. Then this side likewise. So just draw. They will ask you this kind of question, very simple. Pure physics, combined science, whatever physics, they ask you to draw. Don't get this wrong. It's very doable. Okay? So just draw like that. And then after the exam, don't message me and say, sir, I forgot to draw the
Arrows.
yes. Normally 1 or 2 will forget. Or they draw wrongly. So remember, it goes from north to south. North to south means like that. Coming out from the north, going towards the south. That's what it means. Okay? So draw nicely, very easy. Okay. So it's very simple. Okay.